Okay, see, basically, the first important thing is, once you can see, getting a plan. That may be irrespective of any department it is, that may be mechanical, civil, electrical, or anything. But because model comes the next part, that is whether for civil or what they first do, they will not give any approval for 3D, right? They give approval for the plan. How much is the plan? What is the dimension size? Similarly, mechanical students, basically when you do the marketing or when you send your particular designs or anything, the first approval will be made on the 2D designs, then your 3D designs will come to the picture. So now, the whole idea of this particular paper is, if a person, if a designer is unable to have a proper plan, he may not know what 3D he is creating. It is not like a 3D, it will become like a graphics. Just some dimension is there is no proper sizes are there is no proper dimensional requirement is there kind of. So a designer needs to understand how to make a proper plan first, then you need to go into the 3D designs. So more or less civil students, mechanical students, electrical and all, so they know how to make a 2D plan kind of. So 4 questions are there in this paper. I tried to look into all the divisions. If a civil person is attempting, what is his possibility? If a mechanical person is attempting, what is his possibility? If an electrical student is attempting this paper, how he can attempt it? So in line to all of the segments, as well as not so much complicated, because each of them have given a small time, 15 minutes is ideally good for attempting this paper. Now when you look into the first question, see, first question is this exam I give repeatedly, because it's simple as well as some things are there to understand in this particular question. So here, in real time what happens is, I always say every time there is nothing like you are creating newly. When you go for an organization, when you go for upcoming companies, already some designs are created. You as a designer, you should understand that you have to create changes in that one. It is not like the way we are here. What happens? You are doing a number of activities. Every time you start a new one. Every time you start a new one. But real time it is not like that. You have to modify. You have to update. You have to create certain changes. So the first one, when you see here, the overall dimension here is 50, the bottom. But it is mentioned that convert this 50 or change this 50 to 60 millimeters. So this particular first one is in millimeters. Mechanical students are more familiar with millimeters, but certain cases even you should have a knowledge of inches and other kind of conversions. So second question is again speaking in inches, millimeters and kind of. Okay, in the first question, if you see, basically 50 millimeter is there and the other dimensions 10 millimeter is there. If any change is happening to this, how other things are getting affected and how the other dimensions are getting affected. 6.3 is there, distance between each of the semicircle. But the moment it is getting changed to 60 millimeters, why? Because if I give you a ready dimension, you will just create it, you can do mirror. But you will not know if any change is happening, how much is the equidistance. You need to calculate, you need to check it, you need to create it. So, first question, all the things are very clearly mentioned here. And dimension, only change in the dimension is 50 is becoming 60, 10 millimeter. And semicircles are there. The diameters of the semicircles and circles are same as it is, there is no change in that one. And the numbers are same. But only thing is the equidistance spaces are getting changed since the 50 mm is becoming 60 millimeters. Okay, any doubt in the first question? Clear for you, right? Coming to second question. See, second question you are having here. Suppose a civil student, an interior student has to design a cupboard. Or a mechanical student, you will have to design a sheet metal body, a sheet metal rack, for example. So here, dimensions are there in different forms. One is in feet, one is in inches, one is in millimeters, one is in centimeter, like that. So how you will start? Is there any kind of software till now where different conversions will accept in a single shot? There is no software till now where it will accept different conversions in a single point. Only thing what you have to do, you have to convert it. Millimeters, suppose you wanted to design a civil engineer or interior engineers, they wanted to convert it to inches, convert everything into inches. You want to convert into feet, convert everything into feet. You want to convert into millimeters, convert into millimeters. Okay. So here you see there's a 10 feet by 6 feet cupboard or a metal rack or anything. Again you have certain partition. The partitions in the drawing which are shown are not in a parallel. But have you seen any kind of cupboard or a rack with inclined shelf? With a shelf of different combinations? So in this drawing it is like that. What you have to do as a responsibility as a designer, create the shelves perfectly parallel, perfectly in line. Okay. And probably the next shelf is there on the second side. So here only two partitions are there. The next partition is empty. Maybe for someone to hang their coats or someone to hang their blazers, kind of. So it can be there. So 6 feet cupboard, almost you have this much, 10 feet wide compared to this end. And you can see every wood has certain thickness, right? So for example, the benches that you have a certain thickness. So similarly, cupboard will have certain thickness. How much is the thickness? 19 millimeters. So 19 millimeters you can consider for even the shelf where you are doing the partition, because the sides and the bodies. So any doubt you are having? Question is clear. If you understand the question thoroughly, you can finish in 10 to 15 minutes. If you did not understand, it will take longer time for you. Coming to the third question. The third question is simple. I don't mind. So in this what happens? You will have some steps. Mechanical engineers consider some block. That may be a wooden block or that may be a metallic block or anything you assume it. There is no problem. There is no particular unit was given in the third question. As per your convenience, how you feel convenient. Civil engineers, you can use inches, feet, that is up to you. Mechanical engineers, you can use millimeters, no problem. Now, if you see the third question, the drawing is not perfect. Some dimensional text is shown very bigger. Some dimensional text is shown with more precision. More precision means here 25.000. Some dimension is shown here like 35.0. So here there is no uniformity. There is one dimension which is 4.9 in the corner. The text is very bigger. So as a designer, and you can see the blocks, the text item block area 1 is very bigger, block area 2 is very small, block area 3 is little bigger kind of. This kind of drawings, what happens is it creates a confusion for the manufacturer or the site supervisors or an electrical technician if suppose an electrical engineer is attempting this. So here you see what is the outline of this particular drawing and how you are able to define it. And the dimensions always should be outside the body, outside the outline. But here if you see some dimensions are exactly from the body, some dimensions are little here and there kind of. So and here apart from that, from this particular drawing only 3 changes are there. That is the dimension 30 to be changed to 40, dimension 50 and you can see the dimensional text